Hi, Sebastian. Welcome back. And you are in Chicago, right?
I am in Chicago right now. I'm speaking at the local jug this evening.
How cold is it? So in
It,
Celsius, not in
it
Fahrenheit.
is in Celsius. When I arrived, it was like -11 or something. Now I think it's -5. So, but it's also kind of windy and
Okay.
yeah, cold.
And yesterday I was in Sweden, and there were developers from almost polar circle, and they told me
Oh
there is
wow.
two Celsius degree as a 2+.
Oh really?
Yeah, so
So it's
this
warmer
is
there
strange.
than
Usually it's
here in
minus
Chicago.
30 this time, but it was 2+. So Chicago is almost you see the polar bears, right?
Yeah, exactly. That's interesting.
So now you are the chief ESB enterprise service boss office at IBM right now, right? Is it true?
If you want to call it that way.
So what's your official title?
My official title is lead Java developer advocate. So I'm a
Cool.
developer advocate for Java. And
You started with the lead?
that's the name. Yeah,
Yeah,
I
this
do.
is boring. I would expect that you would start with junior, and after a week you were just, advocate and then lead.
Right.
Because if you get everything at the beginning, you know what you can
That's
do.
true. Yeah.
Yeah. Now, we both do, still like Java E, right?
Yes, I do.
Not that you
Kinda
change
use
your
it
mind.
quite a lot.
Yeah, and you also did some OpenShift and Whitefly, and I did OpenShift and Whitefly and Payara. You probably now you are playing with OpenLiberty a little bit.
Open Liberty, yeah,
Yes,
mostly. Yeah.
and because we have a very similar mindset, and we had a chat about serverless.
hmm
And if you look at the definition of serverless, it basically means I don't care about the service anymore. I just push the business logic and I'm happy. So this is basically the
Yes.
definition. And for unknown reasons, some people or speakers expect serverless to be a function as a service. I don't see the connection. So there could be a function, but it doesn't have to be a function, a serverless computing. I think in some definition they say it has to be a function, but I don't know why. I mean, it could be a serverless without functions, or if I package two functions in a module, then it's still serverless, right?
Yes.
Yeah,
Yes, and I agree. I also don't quite. I'm also not too happy with this overly strict definition of serverless, right? That you have to function
yeah,
as a service and absolutely need a new API that nobody knew before, and all that. So
yeah. And I had already a chat with Bruno Borges from Microsoft Asia, and we had a chat about serverless as well. And during the conversation, what I found out that actually we still talking about the servers, and I was in the Jakarta EE block, or what was it? Not block. It was the mailing list at the beginning. They changed, the name from. They say, let's don't talk about servers anymore. Talk about runtimes. And I said, okay, what's the difference? I mean, for me, I can call it, Duke. I don't care. So what's the difference? And no one could tell me this. But I think with Bruno, what I think is server implies it runs all the time. And runtime could imply it starts and dies. So I think this could be an interesting distinction. I still don't care whether the server runs all the time or not. But what really matters, I really don't care about the servers. So people say, okay, I like Java E servers, whatever. It's not true. Actually, for 10 years, I just fully focus on my wars and business logic, and I push it whenever I can, and it just runs. And I get lots of questions. What is my favorite server? Whether I prefer, OpenLiberty, Payara, Whitefly, or Tommy. And what I say, okay, I like all the servers. The OpenLiberty is probably the most innovative right now. And Payara is proven nice, command line interface, and pick what you like. This is my answer. But if you would watch what we are actually doing, even with Docker, what we probably is, I don't know whether you do the same, but we have a base layer with application server. It is basically immutable with particular version, and I rebuild this. If I get a new version, I get a new image. And then I would say sometimes, even in the workshop in Sweden, I pushed 50 times the war to the Docker registry. And this is the uppermost layer. This is the immutable layer.
Yes,
so now,
I do the same.
Perfect.
Sometimes you have layers in between, like what to do if you want to include a special database and you have some flavors, like Postgres drivers. So you don't want to have that in your deployment artifact, obviously. So then you include another, another or a few layers in between for these drivers, for extra configuration, and then this is your new base image for your application server plus, database driver and all that.
And this is the I'd say a Docklands GitHub project, so I call it the configured servers. So you can have, Whitefly, Payara, or Tommy configured servers, and this is the intermediary layer. And the thing is, and then I experiment a little bit with ECS, Amazon, and Oracle container clouds and push to the clouds. And what happens then is you push your base image once to the private registry in the cloud. And then you push, 50 times a day the war to the cloud, and then there is some manual work involved, to restart the server. But basically, you just kill the container and restart the container. And this is, I would say, 60% of serverless already, because in this point of time, I only have actually business logic with a view annotations, and I have I would say, publishing format, which is war. Just forget about that. But the only thing what I'm doing, and actually, I'm sending the war, just the war, to the Docker registry. And actually, Docker does it for me because it sees the uppermost layer. It changed, and only this layer is pushed to the private registry. So I'm misusing Docker as as FTP, let's say. But now, you are also familiar with OpenShift, right? So, and the intermediary configuration step on OpenShift, you could use S2I, source to image. This is mind bending if you start with that. But if you manage to create such an image, what this image actually does is it is a Docker executable Docker image, which is capable of creating the ready to use Docker image with everything inside. So what I did recently for Payara, there's such images are already available for Whitefly. On my GitHub account is called, I think, Payara S2I for a startup client, actually. I said, okay, look, we have one folder, and in this folder you can put your JDBC drivers, whatever you like. Then you can put pre and post commands with your configuration, so just copy and paste whatever they like. You could, of course, replace that with YAML and say, more memory, whatever, but I just use stock ASAdmin commands in a text file, so not a shell script, just a text file, and the war. And then on every change, the image got rebuilt, and there was a config change event, and the whole cluster was not restarted. We had rolling updates and with the reconfiguration of the HA proxy. And this is not that far away. So what you have with that? So first, it was incredibly fast. So the rebuilding of the image, it took, I think, as incredibly fast. I'm still not satisfied, 20 seconds or something. You get a fully executable image with new configuration. And the problem, it is not optimized. So it always rebuilds the server. And I will just improve that. So instead, rebuilding everything. If you notice nothing changed, just add the war and start. There will be about 1 second. But still, let's say 20 seconds is now for the first version is not bad. And the next step would be just take I actually would like to play with it with some cloud. Just use REST. Push the war to the cloud. Then we could have function as a service. A function would wake up and kick off the S2I image or something similar, and just recreate the cluster, and then we are serverless, right?
Yes, and I actually have thought of a similar service or something to offer, where you basically, like you said, deploy your code maybe in form of a WAR file to the cloud, and that's all you care about as a developer.
Yeah, but this is what we did before.
Right. And we could argue on the details, like how you would build that on the on the server, I would actually go more for an approach, something like similar to a continuous delivery pipeline, that you say, you define it in some other approach where you have some base Docker file, and then you just add your WAR file and build it in more the, let's say, traditional way, right? And then you just start up that Docker image that you just built. But it doesn't matter, right? Because
in my case,
for a serverless solution, you only care about what you see as a developer, right? Yeah. And you just want to push the WAR, and that's it. And everything else is hidden from you.
Yeah. In this particular case, it was like the microservice came with the Jenkins file already. So there were my typical unit integration tests and so forth. And one step was this S2I builder.
Okay.
So in this particular case, it just built the server and created the service, and then we had a short stress test, and then the image was tagged, and this was so we still need the Jenkins file for development. In prod, you would just push the image because you don't like to run the unit test again.
Right.
But if you think about this, first, I would say you could implement such a thing in a week. I would say with lots of, or in a day, but let's say with some documentation in a week. And for developers, it's actually a huge benefit, because for me, this Java EE stuff is ultra productive. I mean, I could actually test it locally on whatever server I like, and then use Maven or whatever scripting tool I have, and say after it's built, post this, or curl, just upload this image to there, or not image, the WAR. The WAR is very small. It will be crazy fast, and this is what I don't get, because the whole function as a service is actually painful. So function as a service, if you really package this with lambdas and try to build an application, I mean, it is there's not. I would say it is not fun. So this is like my honest, official way to explain that. And for particular use cases, functions are great, because you could use them as message-driven beans, to listen to events, do something. Like, for instance, we could create a function. Actually, this would be killer use case for functions, like, right? Function is that, but it listens to the network. If work comes in, it wakes up, kicks in the build, and then goes sleep again. So this would be a perfect case for a function as a service, Yeah. But request response, if you really would like to build a microservice which exposes a REST service and build this with functions, this is way too complicated. This is too fine-grained.
Yes, and I mean, functions and function as a service are very great for conferences and Hello World examples. But once you get a little bit more complex, then typically they are not enough. And usually you also have to learn some new API or some new way of doing it, right? Because none of the functions I know use some kind of API that you typically know as an enterprise developer, right? Like to build on Java EE or to build on Spring or something like that. You always have to learn some new things.
And now let's talk about added value of clouds. So now we just have our typical Java EE application where we can inject stuff, and we have our JAX-RS, we have JSON and JSON-B, and probably even JMS, and JMS becomes interesting. But the cloud provider has no services. So if you play a little bit with clouds, all look the same. You get an SDK, which has Maven dependency, and then you always do the same, like authentication, and you have to use a singleton to create an interface. And it's like Java EE was 1945, so a long time ago. And what you could do right now is create a jar with CDI extensions, or just with CDI producers. This would be a good start. And they would implement the cloud APIs, or expose the cloud APIs, and make them injectable. And now we are talking, because if I'm in a Google Cloud, I could just say add inject, how it's called, blob storage, forgot the name, and then I get the interface. And I don't care about the authentication authorization, because it's handled behind the scenes. And this jar could be hidden in Whitefly, Payara, OpenLiberty, in the common lib folder, and just work. And this is a minor step, but from productivity perspective, imagine that, And then first, the cloud providers have added value. Developers have fun, because they only have to inject the thing, don't have to think about authentication, authorization, and just use this interface. And we have our thin wars because this SDK is completely outside. This would be stored in the super image. And this is a killer feature, actually, right?
I fully agree, yeah. This is very, very, very nice way of integrating. I mean, in general, of integrating any functionality that you need, right?
Yeah.
To first of all, package it as a library that's being packaged in the base image, and then also, like as you say, if you need more and more, or if you want to just add some CDI extensions or anything that makes it injectable and usable out of the box.
Yeah.
Yes.
So now you know what to do. So now you have time, as a lead advocate, to test that and speak about it at conferences. And if it works, I will steal your idea again and also speak a little bit about that. But I wanted would I have the Pyar S2I image? And if I will have some time just to extend it with some additional stuff, which could make it more interesting.
Absolutely, and I will totally share that idea with some colleagues who work on Open Liberty or in Liberty full time to do something like that, or to take that idea for the Liberty runtime as well.
Yeah, what Liberty is really nice because they could integrate the modules in the Liberty config. I forgot the name, server config in this XML file.
XML.
Yeah, then you can say, okay, with the server XML, now we have the Google Cloud APIs and make them injectable. And I think this is a huge distinction point, right? But it is actually fun to implement because the work is already done. All the SDKs are available. We only have to wrap them, expose them, which is really fun. And the result is incredible, right? You can say we have a Java EE stock application, and then if you like, we can inject all our services, and here we go.
Right, yeah. Agree.
Yeah, cool. So this is what I never got. Why they don't doing this? Because you ask, and I think no one will implement that because I think from the cloud vendor perspective, they have complete different point of view. They try, they thinking in events and messages, and they don't actually know what we are doing in projects or what we did in projects. Most of the projects are not that exciting, right? So we have a database and we have to talk to the database, expose a REST service, and everyone is happy. And sometimes this is actually most of the applications in all companies I know are like that. And if you are productive with that, then you will win. And productive means it should be convenient, should be simple, and work out of the box.
Now that's interesting. Now I have a question to you. From your experience, how you see the most usage of these Java SDKs being used in projects, right? Like where your Java application actually wants to directly talk to some cloud service. Talk to like the admin.
Yeah. I never created it by myself. What I see the results. So I'm in the projects where they ask me for help, and I saw the bootstrap code is terrible. It looks like I don't know whether you did Java before. We did at the beginning of Java, the whole GD configuration, just tons of Java and nested classes or whatever, and actually a noise code, which is absolutely. If you see this as a Java EE developer, the first question is why we have to do this. It's absolutely unnatural. What I would expect something like GMS context or entity manager. Which can be injected, and now we can inject it. Google Data Storage, forget the name, or SQS Object Store, and there is a NoSQL store or a Cloud Spanner, whatever they have, just make it injectable. Or we could even have, if Lambda functions sends an event, it could be automatically converted to CDI event, for instance. So there could be integration in this. So we have everything already, right?
Absolutely. That's what I did before in a project for Kafka. Wrote a small wrapper, so you emit a CDI event, and then you can just easily do whatever you like with that event.
And Kafka could be JMS or Kafka could be CDI. So both are possible. And both are very easy to implement. Cool.
That's true.
So next question, because I saw you are talking a lot about Istio, right?
Yes.
Now, I use a lot OpenShift, but I cannot imagine which benefit Istio will bring on top of OpenShift. If I'm building my microservices, I have everything already with routing, and what would be the killer feature of Istio on OpenShift?
Right. So you get a lot of, you're right, you get a lot of routing on OpenShift, a little bit more than even a plain Kubernetes can do. What you get more with Istio is all these cross-cutting concerns, such as observability or security between services, on top of your applications without changing the applications. So what I like about Istio, that it actually, in my eyes, it's very, very similar to the mindset of Java Enterprise, that you basically configure everything, like aspect-oriented programming, right? In aspects without changing your code. And out of the box, you get things like monitoring and distributed tracing almost for free. And things like securing the traffic between your services with the mutual TLS and automated certificate generation and checking of all that without changing anything in your application. Right?
But the certificates you also get from OpenShift.
Right, but I mean certificates between services, like cluster internal communication. If you want to secure that as well, and then you can do quite interesting things, like, for example, setting up policies, saying only one service may call the other, but you can actually check that by seeing whether the signage of the signature of the communication was done with the correct key, right? Because you can literally check the key that was being used and things like that. And what I like about it, that you can do all these things without adding it in your application, right?
Yeah, but this is
basically what I do. I do there.
If you hit the wall with OpenShift, then you should look at Istio. This is what I hear from you, right? Because
what do you mean? Say again.
So if OpenShift doesn't fit your requirement anymore because you need more flexible behavior, then it's time to apply Istio on top of OpenShift, right?
Yes, in terms of traffic management, yes, because Istio can do a few more things internally compared to OpenShift. So you can define multiple versions. You can do canary releases very easily, also inside the service, right, without using routes, cluster internal. But it also, even on OpenShift, it adds a lot of observability without touching your application, right? So because what it does, and in my eyes, it's a little bit different also to OpenShift. So these two technologies don't really collide, or don't collide that much, I believe, because you add all these sidecar containers, all these proxy containers with these envoy proxies on Istio to your application, and then you can basically, very similar to Java EE proxies, or pretty much the same idea, and then you can add all these aspects without changing your application, right? So you can say, now I want to add some monitoring out of the box, which is also not done by OpenShift out of the box, right? And you can have some Prometheus and Grafana dashboards that actually ship with Istio if you configure it that way. And the same is true for Zipkin or for Jaeger tracing. If you say you add some tracing, and then what is very nice for Java EE, if you add microprofile open tracing on a runtime that supports both, right, like OpenLiberty, and then you literally can just take the JAX-RS inbound resource, and your server will take the current tracing context and just add it to an outbound HTTP client request. And then you can just use open tracing out of the box, and it just works, and your HTTP headers are being passed. And then you can have a tracing dashboard, which is also provided by Istio. So it adds a lot of nice observability.
But talking about the metrics, so what I'm doing currently in projects is I'm using the microprofile metrics, and but I'm never starting with the technical metrics. What I do, we talk about, there is no name for it, like business KPIs.
Yes.
And you have to implement them, because you cannot just annotate a method. And this is what I start with. This is the most crucial thing, because in my stress test, I'm measuring actually exactly this. And regarding the open tracing, so there's one annotation traced, and it sends the IDs to a central Jaeger tracing server. So this both are solved. So if I would use Istio on top of that, Istio would monitor traffic more, right? So what I get with Istio, I can say, okay, bandwidth monitoring, stuff like that. But I'm actually fighting just for the KPIs and for the tracing, and this works already well in projects. And my feeling is, you how long you are out of projects? So for how long are you now?
I'm actually also doing some projects on the side as well still.
Oh, cool.
And I'm talking a lot with customers and trying to stay in the field, because I believe that's very important.
Yeah, that's very important. So I have really trouble, to sell that. But if Istio comes on top of that, so then we have to configure OpenShift and we have to configure Istio. And I would also challenge developers to still expose the business KPIs and the trace.
Yes, and I very much agree. So, and you're totally right. So what Istio adds, it's all just technical, because it does not know about your business, right? Mm-hmm. And actually, your business metrics are far more interesting and far more important, because this is about your business domain, right? It's right. The same with classes. You can have the coolest framework, but it will never know about your use case, because it can't, right? You always have to implement your business logic, and that's the most important thing of your application. And the same is true for business metrics, right? Like saying, okay, how many cars have I sold over the last hour, and what is the revenue we make, and all that. And you will never do that with technical information or technical metrics. So everything that Istio covers in regard to that is just technical.
Yeah.
So as this doesn't collide, and it's like a nice to have feature on top of it, especially if you don't use anything else in container orchestration that provides this out of the box. And it just comes basically, for free. It's something like I see quite like application server monitoring, like JMX, that is just being provided out of the box. As a developer, you don't care that typically that much about CPU and memory consumption and all that.
Yeah, exactly.
Probably, graph pool size and everything that your application server provides. But it can be very helpful information that's just there. And, the application server is being forced to provide it, right? Mm-hmm. So if you use Istio, and it's, in my eyes, quite easy to install, and it just adds that and provides it out of the box, then you have the technical metrics as well, right? Without doing much, in my eyes.
I think I found a killer feature for Istio. Would you like to hear?
Yes.
Databases. So we have sometimes databases running on OpenShift cluster, and then I could install Istio as a sidecar on the database and monitor traffic to the database, because this is relevant. How much bandwidth can the database still handle the load? Is it possible, and is the database doing anything? Because I've actually no influence on the database. So there is some internal database monitoring, but it's a lot harder. I have complete control over my microservices, and I expose a lot of things, but I have no control about the database. So I think installing Istio sidecar on a database pod could be interesting, like Postgres.
That's an easy way to observe that, for example.
And we already had that trouble in one project where there was so much traffic going on that a database had no chance to write all the data because the disks were too slow. And with that, we would see, immediately that the traffic is too high.
Right. Yeah, it very much depends on always what you want to measure and sample, right? And what I'm saying is Istio and service meshes in general, that's not a silver bullet, like never. It's just an easier way to have some more technical information, some more a little bit more observability. If we're talking about observability, right? It's also has a few other features on top of your application being provided out of the box, right? And that's all. That's it. Of course, you have to do all these other things yourself, and there are many ways how to provide a better observability. And as always, if you implement it yourself, it will always be better suited for your domain. So that's just natural, right? Yeah. If you implement that yourself, you can just immediately emit what you want to measure or what you want to expose. Mm-hmm. So that will naturally fit your domain better. And in most of the cases, you have to do something like that. Mm-hmm. But what I'm just saying, it provides a lot of things out of the box.
Mm-hmm. And two stories. One was, I think 2 years ago, a task force, and some business processes didn't work as expected. And they asked me to help. I said, okay, what do we need? Monitoring, because what I would like to do is to to expose some metrics so we can look at the system in production and see what happens. And they said, please note, we have already 30 dashboards and no one knows what's going on. We don't like another dashboard. And I took a look at the dashboards, and this was exactly what you said, traffic, CPU usage, I suspect even weather, in the basement. But no one knew actually what the hell is going on. And what we did is, deactivate all the metrics. And what we did is we specify just a counter, how many successful processes happened and how many failed. And this solved everything. And this is my constant struggle. Developers love dashboards without effort. And this is why Hystrix was so popular. I was Java user group in Hamburg. And I say, who the hell needs Hystrix? I mean, this is crazy complicated, and you have to build command patterns, strange things, and the application server does it for years. Why we should use it? And after the show, a consultant came to me saying, with Hystrix, I can provide my customers view dashboards, and it looks a little bit more professional, and I can sell already some of my services. So it looks professional, but the added value is zero. This is the same as you will expose in a car, I don't know, temperature of the exhaust pipe. It could be interesting and nice to look at, but it's completely useless.
Yes, and I very much agree with you. And in both ways. So you always have to ask whether that provides helpful information. So you should not invest much effort in building dashboards for technical metrics, things like that. And
but everybody does it, right?
I know, and it's more like I recently had a similar conversation, and I heard it's more like a feel good factor. Right. Yeah. So it looks professional, it looks nice, and you can have a look at the dashboard and there's still something going on, and you say, okay, great, like exhaust pipe temperature is still okay, but you have no clue what that means. And if something happens, this information will not help you.
We should sell lava lamps, These are the just without no connection to the applications, or
just randomize.
Or randomize a dashboard. This is what
you don't have the data; it just shows something.
Commercial software, just no kidding. So in the project, what I told you before, they observed the garbage collector behavior. I don't know why, and they say, take a look on this. And they ask me, does it look right? I say, as long as the system works, I don't care. So I mean, it could be right or not. I don't know your system. I mean, this won't be your problem, right? And it wasn't. But this is what. What I don't like about Istio is because everyone is interested in Istio even get more useless metrics. So, and then, but I'm just searching for killer features. And what with your conversation with you, the database thing is really useful. Just to monitor traffic to database, because this is not easily possible without Istio. Because I cannot install, I have no influence on JDBC drivers on Postgres, for instance. You know what I mean?
Mm-hmm. Yes. And if we talk about killer features, and another thing that I see, so the security part is quite nice to have, but cluster internally, I'm usually not that much interested in that. What I see as a big feature is the whole traffic management, because this is quite powerful. So, for example, what you can do, what we actually did, was to basically control Istio from the continuous delivery server, and then use the whole user zero downtime deployment approach with canary releases and all that, using the Istio routing, right? So you say the service is being provided by so and so many instances, that comes with Kubernetes and OpenShift, but then you have a more complex approach how to deploy it, right? Like, first of all, just deploy like 1% of the deployed and just route 1% of the traffic, and then increase that slowly, right? And that's all automated. And then once, nothing happens and you don't get a lot of errors, then automatically that just increases until you have a full deployment on it, right?
But you can do this the same with OpenShift, with the annotation of the routes, right?
Cluster externally, yes, but not internally. No. Because then internally it would need to use the route, right?
And you did it internally? You had the news to use that internally?
Yes, if you have multiple microservices that just communicate internally, and you just want to deploy one that is used internally and maybe not even called from externally, but also other servers want to use them without having downtime, right?
Yeah.
So then the service uses that, and then just without knowing, uses a new version or then slightly new version, and slightly increases the load on the new version and that, and without using routes, right?
Exactly.
Or actually, then it doesn't even matter, because once you use these Kubernetes services that are handled by Istio, then you always use the same routing.
So far, we're using mostly routes, and therefore it works.
Yes, true. Because you can do a similar thing with the routes, and then also connect.
Because the routes are generated usually by convention, so you know what the name is. And with the routes, this is what I meant. But again, the database thing, this is great, because I get lots of questions about Istio, and I didn't have a killer feature, but installing Istio on the database pods or whatever we have out of control. For instance, some external pod, which, I don't know, what we have, Camunda or whatever, where I have no influence, some external process. This is what is interesting to monitor. Then is Istio actually a killer feature, I would say.
Actually, you also monitor everything that you don't have inside your cluster if you have connection to external services, because all the connection goes through a proxy, and then the proxy also can have the HTTP request for that, right? Like, how often do I call whatever GitHub API and things like that, and you can monitor it just out of the box, like without actually installing everything. That's all injected automatically.
Cool. So this was worth exactly another idea. So
another nice feature that I'm actually using for tests is that you can make connections slower and make them fail with Istio with these proxies, right?
Yeah.
So it's of course only a testing feature, so don't do that in production. But you can make requests slower and make them fail. Like on so and so many percent will fail, and I found that very nice, because many times I just wrote some test code inside external backends that were also under my control. If you send this extra token, then make it slower, or then just fail just for test purposes, or you need a test Double or test mock server if you just want to make something fail to test your resiliency, for example, right? And with Istio, this is done very simple, because you just annotate your route that you have anyway with some extra fault, and then it's just false.
This is a great thing, because what you can do with it, test your timeouts, for instance.
Yes, exactly.
Of the other microservices, and the bulkhead settings, and if you need a circuit breaker,
right, make it slower, make it fail. Yes.
Yeah. This is also an added feature I see. Cool.
You are on top of it, it's just nice that it adds without overhead. So I fully agree with you. And it would, if it would be hard to set up, then I would say no. Who cares, right?
No, perfect. So I learned a lot, and now you are at IBM, and you have another killer tool, widely underappreciated, and it's way easier than Kafka. You know what I'm talking about?
Way easier than Kafka. Then you talk about some eventing.
MQ series.
Yeah.
What I'm talking about is not easy to set up, but it's very easy to use. And what happens several times in projects, most of large clients have already MQ series set up. So this was, the whole world is running on MQ series, insurance companies and so forth.
Yes, everything runs through.
Yeah, and they wanted to have Kafka. It's like, look, Kafka is properly nice, but if you try to make Kafka run smoothly in a cloud, forget it in a project. I mean, just go to the tutorial and take a look what you will have to do, because Kafka is like everything else, like ActiveMQ. It is based on the idea of a singleton, which is clusterable, and there is a zookeeper which cares about that. And you will spend a lot of time of setup, so we don't even have the time in the project. So my suspicion is most of the projects are using Kafka, like Hello World, and they are really glad that some events are sent and received. But this is like we would use, a central GMS server on one single machine, and if it dies, everything died. So it is not really responsible to do such a thing in projects, unless the project, I don't know, pointless, or the events is just nice to have events, which usually they aren't. And what we did is, if there is MQ series somewhere, with Java E, is incredibly easy to talk to MQ series via GMS. And incredibly easy is there is the JCA connector, which works with most servers, and should also work with OpenLiberty, I suspect.
I suspect so.
Yeah, but listen, you only have with message-driven bean, you only need a single annotation, and to send a GMS message, GMS context, 2 lines of code. If developers saw this, it killed Kafka. Because it's a way easier. There is nothing to set up, and we don't care. And this is proven technology, I don't know, probably 30 years old from IBM. And I think now is your job to investigate a little bit more and popularize that. What I also know, there is like managed, really easy to set up MQ series environment which should run on OpenShift. And I mean,
and there's also cloud service and all that.
Yeah, but this is like no one talks about that, because for me, Kafka is completely different to GMS. Kafka is a mix of persistence and messaging, because it stores everything in a file.
Yes,
and GMS
has
is
multiple ways how to run.
Yeah, and GMS is just messaging. So 2 complete different use cases. And with MQ series, you get, of course, deliver once and only once persistence queues, which is this what actually you always need if you need messages.
Yes, I
yeah,
agree.
And you also get publish subscribe. And and no one talks about that. It seems like, use Kafka, and no one also talks how hard Kafka is to set up on OpenShift or in the cloud. If you use Kafka, which I use Kinesis, something managed for you, but don't try in your projects. And this is like, for unknown reasons, developers just like Kafka and they like to play with it. And for me, if I look at this, it's like, you are all crazy. I mean, in one day, you will have to deliver some business code. We cannot play with Kafka all the time, right?
Yes, and I fully agree with you. I've seen the same in projects, and I mostly see the difficulty of setting it up. Like actually not even integrating it on the code, and with EE, you can same story, do some CDI integration or something like that. But I see the biggest the issue with Kafka actually in operating it, right? Like in setting it up in the cloud, and you need the zookeeper, and then you just want to make sure that it all runs in like Kubernetes on the correct hosts and nodes and all that. And this is totally not trivial. Fully agree. Why people are so interested in it, I don't know. Maybe they do a good job in conferences and speaking about it. And I see a lot of like people being interested in Kafka, or say they have to have it. But yeah, fully agree. Especially on the way how to operate it. You always, as a developer, you have to know. That's my personal opinion. You have to know what's going on, even with your your messaging or your integration technology, right? Like, is it actually exactly one semantics what is being done, and what happens if the whole thing goes wrong, right? Is it persisted somewhere, and how is my cluster managed? Because if you have a single point of failure or a centralized solution, then you have a problem, right? Later on in production.
Yeah.
Then no events arrives and you don't know why, right?
So the first question I ask myself, okay, we running in somewhere in clouds or OpenShift or somewhere, and now where is the queue or where is the file? It has to live somewhere, right? And if it lives somewhere, it has to be replicated and has to be consistent. And then you will have to set up persistent claims and think about which volumes you choose or whatever.
Yes.
And then this is end of story for me. So, okay, we could do this. It will take 1 week or 2 weeks, because what I would also do, stress testing, see whether it actually works. And it is complicated, but you cannot tell that clustering of application servers GMS was complicated, and or complex, and Kafka is just fine. So this is the complexity is exactly the same because the problem is the same. Yes. The application servers gather all the messages in a singleton, and if it dies, another singleton wakes up and takes the messages over, and they are replicated with InfiniSpan or files or databases. So you have exactly the same setup as Kafka. So for me, no difference. The only difference is IBM has 30 years experience with MQ series, and I think they exactly know what works and what doesn't, and there could be a OpenShift template which is set up properly. And I think this will be the next killer feature.
Mm-hmm. Yeah, that or in Helm chart and proper integration in cloud services.
Yeah,
that's very good feedback. Yeah,
this is because lots of clients have MQ series and they don't even get the idea how easy it is to talk to this. It is a message-driven annotation. I think you need 5 properties, and you are golden. Some are strange, like channel manager, whatever. You have to know them. But if you get them from operations, it's like in 5 minutes I can talk to you via channel.
Mm-hmm. True.
So now is your job, to talk to MQ-Series people. And it could be very easily integrated with OpenLiberty. And if you have JMS integration to MQ-Series, the next integration could be, or even you could use CDI events. Who cares, You have the JCA connector, exactly. You can write a bridge, and CDI events is also good. But JMS2 is not that bad. It's also lean. I mean, this is one-liner.
Yes, I agree. And from my experience, the code integration in that technology is usually not the issue, right? Like you either write some extension, and if you want to use CDI, then you use that. Or if you want to have your own code, well, who cares, right? Then you write your own adapter.
Yeah, cool. So we covered a lot of ground. Do you have anything to ask or any topic?
I don't think so right now, actually. I think we covered a lot, and the rest, is it should be clear anyway, like Java EE or Enterprise Java related things.
Yeah.
I think we also agree a lot on the interplay between microprofile and Java EE. How useful that can be if we use if you use a runtime that supports both Java EE and microprofile, and then just use the projects accordingly of microprofile to enhance, like metrics and
absolutely
resiliency and all that. I think
it's surprising. Nice, we have like shared mind. So if I ignored microprofile for about 1.5-2 years completely, because they were the esoteric runtimes I was absolutely not interested in. Yes. And now every server ships with microprofile, and this is great because I don't have to ask for permission. All my clients have the servers. I just use microprofile and Java at the same time, and problem solved. And this is the killer feature, I would say.
Mm-hmm. Yeah, I agree.
Perfect. So have a great day.
Thanks, you too.
You have jet lag?
Thanks a lot for setting that up. No, actually, I've been in the US before, so I just switched like time zone for 1 or 2 hours yesterday when I flew here from Canada. But
always on the road.
Always on the road right now, yeah.
So the next podcast session with you, I would expect that you explain me how great MQ-Series on OpenShift runs and how easy it is to send a message. So this would be cool. Do a proof of concept, really. I think it is worth. And what we should promote, Jakarta EE blogs. Are you already signed up?
Yes, and I'm listed in these Jakarta EE blogs as well.
Cool.
I think I was part of the newsletter that just recently came out. So to everybody who's listening, check out the Jakarta EE newsletter. I'm not quite sure how often that is being sent out, but make sure you sign up for it, and then you also have interesting content from not only Eclipse Foundation, so not only organizational and political stuff, but actually technical content of all outside open source contributors.
Mm-hmm. They try to extract some information for the article from my blog, but they told me it is not usable. But what I would really like is that more and more bloggers just sign up to Jakarta EE. I don't know whether 10 years ago, there was Java blogs. You remember that?
Yep.
This was like a portal which all Java blogs. At the beginning, it was great. And something like this could happen with Jakarta EE blogs. So then we have a single destination with the recent interesting, or different point of views regarding microprofile and Jakarta EE.
Yes, I agree, and there are a lot of bloggers out there, I think, who just like us always share like small tips and tricks on how to use Hibernate, JPA, and all that. And if you have a single source as a developer, where you could just go and say, oh, that's a new interesting trick that I didn't know, then this could be a quite great resource.
Yeah, exactly. So people can find us on Jakarta EE blogs. So we only have this. Where people can find you, except your blog, is Twitter. What is your Twitter handle?
Twitter is @DaschnerS. That's always confusing because last name first, Daschner, and then the S for Sebastian. Or just on my blog or on my website, they're all cross-linked.
And what's your blog, website, and GitHub? You know this?
GitHub is @Daschner.
Yeah.
So that's the confusing part because then it's first name first.
Okay.
And my website is Sebastian-Daschner.com.
Perfect. So thank you. Enjoy Chicago and go out and you have now Polar Circle filling in Chicago.
Yes, I do.
Okay, bye.
Bye.